The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hi everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们，大家好，欢迎走进今天的课堂，走进诺贝尔化学奖。今天我会向大家介绍一位颇具传奇色彩的科学家。Today I will introduce you a legendary scientist who is Koichi Tanaka. When you hear about a Nobel Prize winner, what would you think? Genius? Superman, gifted person, a big shot? Can you imagine an ordinary person without holding a PhD degree or faculty position could win a Nobel Prize? Yes, there is one. It's Koichi Tanaka. He is believed to be the only person who have won a Nobel Prize for science without a PhD degree or even a master degree. He's not a professor either. Mr. Tanaka was a Japanese scientist. He won the Nobel Prize in Chemistry 17 years ago. He worked for Sumatsu Corporation as an engineer in the R&D department. He developed a new ionization method for mass spectrometry analysis. That is matrix-assisted laser desorption ionization, usually called as MADing. Together with Professor Johnson from Yale University, they shared the Nobel Prize in Chemistry for their development of soft desorption ionization methods for mass spectrometry analysis of biological micromolecules. What is mass spectrometry, and why Tanaka's work is so significant that he could win a Nobel Prize? A mass spectrometer can be considered as a precise balance. It weighs ions in the gas phase and determines the masses of individual atoms and molecules. In the ion source of mass spectrometer, neutral molecules can be ionized by different techniques that dissociate to fragment ions. All the produced molecular ions and fragment ions will enter the mass analyzer behind the ion source, with which they can be separated according to their mass-charge ratios. But old mass techniques can only analyze small mass ions, such as atoms and small molecules. For example, in the Second World War, the Manhattan Project designed a mass spectrometer to separate uranium-235 from uranium-238 for making atomic bombs. However, the biological micromolecules are relatively fragile, and their structures and components are easily destroyed during the ionization process. So they are very difficult to analyze by mass spec. From the first time in the history of MS, MADing introduced the soft ionization of analyzed samples. In multi-process, samples are mixed with certain matrix, which is the ionization agent. It's crystallized on the metal plate to form a sweet spot. When the laser beam is irradiated to the target spot, it dissolves and ionizes the analyte in an indirect manner. As a result, high mass ions can be produced by this technique. The advantage of this method is that the protein in the solution can be ionized, and even the protein in the living cells can be ionized. So the structure of live protein can be obtained. Therefore, Tanaka's work makes a progress of applying MS in the fields of biology and medicine. We may have heard of many stories from the internet about how Tanaka obtained the Nobel Prize. Many of them said he has found the multi-ionization method from an experimental error. Is this really an accident? Let's hear what he said.
On hearing the news that the Nobel Prize was decided to be given to me, at first I was very much surprised. Also, I felt somehow uneasy that the award is for chemistry, which was not my field of specialization. After some time, I started to feel that I am very much honored to receive this award and convinced myself that I have accomplished something that can be recognized. So today, I would like to introduce to you that what was the background of the invention and that I made, how it was achieved, and who was contributed.
Without having studied the theory of ionization coupled with my paucity of knowledge in chemistry, I single-mindedly, day after day, repeated trial and error experiments with the candidate substances. Continuing this regimen tirelessly, I felt like I had become one of these substances and the instrument. However, a solution was not easily found. 17 years ago, Tanaka sat leave me alone at a press conference. Then he went back to the lab. He devoted himself to experiments and seldomly showed up. Tanaka returned to the ordinary life. He still wore his lab clothes and refused to promote it at work. Everything was just like not having won the Nobel Prize. 17 years later, it was not until Tanaka returned to the public that people realized that he had never left the front line of scientific research after he became famous. The name of Tanaka was seen again with his latest research published in the leading journal Nature. He and his team developed a new method that, with just a few drops of blood, Alzheimer's disease can be predicted 30 years in advance, before the onset of the disease. In February 2019, NHK invited Tanaka to attend a documentary production as part of Review Scientific Achievements in 30 Years. At this time, Tanaka has already had a self-confidence in his eyes, compared with himself 17 years ago, who was shy in public, like two different persons. I met him in July of 2019 at the conference of Sumatsu Innovation Summit. He's still a hardworking and modest person, always with smiles on his face. He patiently explained his recent work to us and had a group picture with the chemist from China. That's the leading role for today's class. Please let me know how do you think. Thank you.
大家好，田中耕一曾表示，自己并不是最好的获奖人选，还有比他更合适得奖的人。对此，诺贝尔奖评选委员会给出了强有力的回复，说诺贝尔奖是用来奖励那些 率先提出改变人类思维方式的原创性成果。你的得奖是慎重、公平、公正的决定。当媒体提到田中耕一的研究成果时，他的回答关键词只有一个，就是兴趣。或许他正在提醒一个目前已经被很多人忘记的问题：学问的源头就是兴趣。2002年，田中耕一因为一些偶然的因素，获得了世界最高奖项的肯定。17年后，他因为坚持自己的研究方向，成功发现了诊断顽疾的未知物质。他的发现确实有偶然的因素，但更多是坚持和坚定带来的必然结果。其实，早在40年前得知生母病逝的时候，田中耕一就下定决心投身医疗研究。那个幸运的诺贝尔奖只是给人们提了个醒，意外能让你幸运一时，但坚持却能让你幸运一世。好啦，本次课到此结束，谢谢大家，再见。